Hello guys, this is Vishnu and today let us see about copolymerization and it's a concept video. So basically what are polymers? Polymers are materials made of long repeated chains of single or more monomers. So the materials have unique properties depending on the type of monomer being bonded and how they are bonded. Some polymers bend and stretch like rubber and polyester. Others are hard and tough like epoxies and glass. So as you can see over here, it's nothing but a polymer consisting of one monomer and this is another monomer. These two uh, are linked with single and double bonds, and this is how a polymer is. Uh, I mean, this how the polymers will be with the number of monomers. In this case, in this image, there are two monomers. Mm, So that's it about the monomers. They are not, I mean, polymers. They are nothing but the multiple number of monomers bounded to them, bounded to each other in a different manner. Or so copolymerization. What is this? So copolymer is a polymer material that consists of more than one type of a repeating unit of different monomers. So um, different monomers are being used and can be of either step growth polymerization or chain growth polymerization. Acrylonitrile butadiene styrene, which is ABS polymer, and nitrile rubber ethylene vinyl acetate are a few examples of copolymerization. I mean, by the process of copolymerization, these three, um, one, two, and three, are I mean are being produced. So types of copolymers. Well, there are linear copolymers which and branch copolymers, where linear copolymers consist of a single main chain and includes alternating copolymers, statistical copolymers, and copolymers. Whereas branch copolymers consist of single main chain, which one or more polymeric side chains and can be grafted, sharp star shape, or having other architecture, star shape, or let's make benzene uh, sort of benzene like that. So linear copolymers. Linear copolymers are of types where over here we are talking about block copolymers, alternating copolymers, periodic and static copolymers. So block block copolymerization. Block polymers comprises two or more homopolymer subunits linked by covalent bonds. The union of the homopolymer subunit may require an intermediate non-repeating subunit known as junction block, or diblock copolymers have two distinct blocks. Triblock copolymers have three, and technically a block is a portion of macromolecule comprising many units that has at least one feature which is not present in the adjacent portions. A possible sequence of repeating units A and B is a triblock copolymer. Might be look, I mean, this might look like this. However, it consists of a monomer where A is a monomer and B is another monomer. This is B and this is A. So over here, one, two, three, four, five, six, seven, seven A monomers linked, and B also one, two, three, four, five, six, seven B monomers, and again over here five A monomers, and actually this symbol represents that they will go so on. I mean over here not only not five but there will be seven. I mean it's a repeating chain which consists of A and B. Over here two monomers are there. So I mean, these are sort of like blocks. This is A block, and this is the B block, and again A block, which consisting of 7 A's. So this is how a block copolymer looks like. So over here, this is commonly known to be like tri-block copolymer. They are mentioning it. So let's go to the others. Alternating copolymerization. An alternating copolymer has regular alternating A and B units and is often described by the formula AB, 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 AB. Alternating in the sense, I mean, which is not regular, which is irregular. So as you can see, A, then B is there, then again A is there, and B, A, B are just alternating. As you can see, this is if a, I mean, where A and B are monomers. So this is I mean, these kind of polymers are known to be alternating copolymers, as their monomers are alternating each and every time their positions, if we specify, and is often described by the formula this, or this is the basic formula where n is the number of monomers are present. So the molar ratio of each monomer in the polymer is normally close to 1. So when which happens when the relative ratios R1 and R2 are close to 0, as can be seen from the Mayo-Lewis equation. Okay, and the basic idea of the alternating copolymers is this, where the monomers keep on alternate. And let's go to the next slide. Periodic copolymerization. Periodic copolymers have units arranged in a repeating sequence for two monomers A and B. For example, they might form the repeating pattern AB, A, B, B, A, B, 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 and so on up to N. So, in a repeating sequence, they are mentioned. They have mentioned for two monomers A and B, and this is about periodic copolymerization, where they just multiply. I mean, they're just increasing themselves as the chain increasing as the chain increases. I mean, this um, example monomer. This example does state that. And let's go to the next one. Static copolymerization. In static copolymers, the sequence of monomers residues follows a static rule, statistical rule. If the probability of finding a given type monomer residue at a particular point in the chain is equals to the mole fraction of the monomer residue in the chain, then the polymer may be referred to as truly random copolymer. So over here they're using maths, where if the probability of finding a given type monomer, well, they will mention what monomer it is, and residue at a particular point in the chain. So let's say there's some a a b a a b b b a b b b. Let's say this is one of monomer. So this is how we can represent. Let's say this is a monomer. I mean, um, not monomer, it's a polymer. um, well, what they're saying, like, the probability of finding a given type monomer, let's the given monomer, let's say it's A, for example, a residue at a particular point in the chain is equals to the mole fraction of that monomer. I mean, this monomer's mole fraction should be equal to the particular point in chain. The monomer residue in chain, then the polymer may be referred to as a truly random copolymer. So according to the statement, they are like uh, the I mean, the if let's say the monomer mole fraction value is, let's say, which will match with our example 1, 2, 3, 4, 5, 6, 7. Let's consider it as 7. So if monomer A is present in seventh place of this polymer, then this A is, I mean, A is considered to be as a truly random. Not only this A, but the whole thing is referred as a truly random copolymer. And branched copolymerization, there are a variety of architectures possible for non-linear copolymers. Beyond grafted and star copolymers discussed below, or other common types of branched copolymers include brush copolymers and cone copolymers and etc. And that's all, guys. Thank you.